Hello all. So the topic that we are going to discuss under the DC circuit analysis for today's session is the nodal analysis. So we know that the previous topic that we have discussed is the mesh analysis, which utilizes Kirchoffs voltage law and which is used to find the loop currents I1, I2, I3, etc., which depends on the number of loops available in the circuit. And as far as the nodal analysis is concerned about, the law that we are using is the Kirchoffs current law. The Kirchoffs current law states that on a node termed as N, the sum of the incoming currents is equal to the sum of outgoing currents. So for example, this is your I1, I2 and your I3. So the incoming current is your I1, so which is equal to your I2 plus your I3. So we can know better about the nodal analysis and the utilization of Kirchoffs current law by going into a problem. So consider this complex circuit as this is an 3 ohms and this is 7 ohms. You are having one another resistor and there is one another resistor which is 1 ohms here, and we are having a current source which is a downward current and whose value is 18 amps, and this current settles here, and we are having one another resistor whose value is your 5 ohms, and there is a current source from this node to this node which is like an upward current. So and the value of the current is your 25, and there is one more current which is from your node to this node. So this value of the current is your 3, and we are having a resistor in between the first and as well as the last terminal. So and the value of the resistance is 4. Now what we have to do in this nodal analysis is, first we have to fix the number of nodes in the circuit. As far as this circuit is concerned about, you are having 4 nodes. So this is your node 1, node 2, node 3, and this is your node 4. Let this node be called as your V1, and this is your V2, and this is your V3, and this is called as your V4. So of the 4 nodes, the number of nodes is N, and the number of equations that we are going to frame is called as your N-1, and the number of unknowns is also N-1. So the number of node is N, the number of equations that we are going to frame is N-1, and the number of nodes is also number of node equations, and as well as the number of node values that we are going to find is also N-1. That means of the 4 values, one value we are going to take it as 0 volts. Now what we have to do in this is, we have to find the current direction for all the elements. So for example, for this 3 ohms, let me take the current direction is like this, and for this 7 ohms, let me take the current direction like this, and for this it's a downward current, and for this also it's a downward current, and for this 4 ohms, let the current direction be like this. Let me term the current values as I1, I2, I3, I4, and as well as your I5. So but whereas the known current values, let you take it as your IA, IB, and this is called as your IC. So the value of the current I1 is equal to, the I1 is the current value which is flowing between your node 1 and node 2, which is called as, this is an arrowhead, this is head, and this is tail. Tail potential minus head potential divided by the resistance value, so which could be given as your V1 minus V2 by your 3. And the current I2 is flowing through this first 1 ohm, so which is your tail potential is V2 and your head potential is V4, and the value of your V4 is equal to 0, so which is V2 minus V4 divided by your 1. So since your V4 value is 0, we can write it as V2 by your 1. And the value of your I3 is, it is in between your V2 and V3. We could write it as your I3 is equal to V2 minus V3 by your 7. So V2 minus V3 by your 7. And the value of your I4 is equal to, so which is between your V3 and as well as your V4, which is your V3 minus V4 tail potential minus head potential. So V3 minus V4 divided by your 5. So value of your V4 is equal to 0, which could be given as your V3 by your 5. and the current I5 is equal to, which is your tail potential is your V1 and your head potential is your V3. So V1 minus V3 divided by your 4. So these are the 5 currents that are available with the resistances of this circuit, and we know that value of your IA is your 18, value of your IB is equal to 25, and the value of your IC is equal to 3. So at node, let me take it as at node V1. So we know that by Kirchoffs current law, at node V1, the sum of incoming current is equal to sum of outgoing current. What are the various limbs that is coming out of your V1 is 1, 2, 3 and 4. In the limb number 1, I5 is outgoing, limb number 2, IC is outgoing, limb number 3, I1 is outgoing, and in limb number 4, IA is outgoing. So no incoming currents. Incoming current value is equal to 0, which is equal to IA plus I1 plus IC plus your I5. So we can write it as the value of your IA is 18 and the value of your I1 is V1 minus V2 by your 3, and your value of your IC is your 3, and value of your I5 is V1 minus V3 by your 4. Now what we can do is 18 plus 3 is your 21. 21 plus V1 by 2 minus V2 by 3, V1 by 3 minus V2 by 3 plus V1 by 4 and minus V3 by 4. We are separating the denominators for all the header values. So this 21 we could take it to the left side, so it is minus 21. So it could be called as your V1 by 3 and as well as your V1 by 4. V1 by 3, 1 by 3 is 0.33. 1 by 4 is your 0.25. 0.33 plus your 0.25 value is 0.58. So your 0.58 V1 and your V2 value is 1 by 3 is 0.33. So minus 0.33 V2 and your V3 value is 1 by 4, which is 0.25. So minus 0.25 V3. Now this equation 0.58 V1 minus 0.33 V2 minus 0.25 V3, which is equal to minus 21, is the equation number 1. Secondly, what we want to do is, again we have to apply at node V2, we have to apply Kirchoffs current law to find the value. How we can apply is, so at node V2, what are the various incoming currents and various outgoing currents? So your V2 is connected to 1, 2, 3 and 4. So that means 4 currents should be there. Okay. Your IC is incoming, your I1 is incoming, your I2 is outgoing, and as well as your I3 is outgoing. So by Kirchoffs current law, the sum of incoming current is equal to sum of outgoing current. So incoming is your I1 and as well as your next current is your IC is incoming, and your I2 is outgoing and as well as I3 is outgoing. I2 is outgoing and as well as I3 is outgoing. So as far as yours is concerned about, your value of your I1 is V1 minus V2 by 3 and value of your IC is, your IC value is equal to your 3 and value of your I2 is V2 by 1 and value of your I3 is V2 minus V3 by your 7. So what we can do is keep your constant here, but whereas you take this value to this side, right hand side, so that means minus V1 by 3 plus V2 by 3, that means plus V1 by 3. When it is taken to the right hand side, it has been written as minus V1 by 3, minus V2 by 3. When taken to the right side, it is written as your plus V2 by 3, and V2 by 1 plus V2 by 7 minus V3 by 7. Now what we can do is, so this 1 by 3 is your 0.33. So minus 0.33 V1 minus 0.33 V1. Again this 1 by 3 is your 0.33. And your 1 by 1 is your 1 and your 1 by 7 is, you have the calculator, you find the value of your 1 divided by your 7, whose value is 0.143. So the value is your 0.143 and here also 0.143. Now what we have to do is, your V2 value is 0.33 plus 1 plus 0.143. So you can write it as 0.143 plus your 1 plus your 0.33. So we can write it as 1.473. So plus 1.473 V2, and your V3 value is minus 0.143 V3. This value is called as the total value is called as your equation number 2. So your equation number 2 is minus 0.33 V1 plus 1.473 V2 minus 0.143 V3, which is equal to 3. And lastly, what we have to do is we have to find the V3 equation, third equation. At node V3, you have to apply your Kirchoffs current law. By how many limbs are connected? Lastly, what we have to do is we have to apply the Kirchoffs current law at node V3. So at node V3, we know that how many limbs are connected? 1, 2, 3 and 4. Your I5 is incoming, your I3 is incoming, your I4 is outgoing, and as well as your IB is incoming. So 3 incoming currents and 1 outgoing current. So you can write it as I3 plus your I5 plus your IB, which is equal to your I4. So the value of your I3 is V2 minus V3 by your 7, and your value of your I5 is V1 minus V3 by your 4, and value of your IB is your 25, and the value of your I4 is V3 by your 5. So you can write it as, you take your V3 by 5 inside, so you could write as V2 by 7 minus V3 by 7 plus your V1 by 4 minus V3 by 4 minus V3 by 5. That means you are going to bring this V3 by 5 inside, and you are going to take the 25 outside, so it's equal to minus 25. So this 1 by 7 already we have found it as 0.143, and here it's again 0.143, and 1 by 4 is your 0.25, and 1 by 4 is 0.25, and this 1 by 5 is your 0.2. So now what you can do is, this is your V1 value, so plus 0.25 V1, and your V2 value is your, only this value is there, so plus 0.143 V2, and your V3 values are, all the three values are negative values, so you can add all the three. So when you add, you will be getting as 0.143 plus your 0.25 plus your 0.2. So when we take, we will be getting as 0.593. So minus 0.593 V3, which is equal to your minus 25. So this is your equation number 3. So your equation number 1 is this, and equation number 2 is this, and equation number 3 is this. By using these three equations, you are going to you are going to get the value of your V1, V2 and V3. Now type as equations, and number of unknowns is 3 unknowns. So your A1 value, what you want to do is your V1 value, A2 is your V2 value, and B1 is your V1 V2 value, and your C1 is called as your V3 value. So you could write it as, so your A1 value is 0.58, and your B1 value is minus 0.33, and your C1 value is your minus 0.25, and your D1 value is your minus 21. And your A2 value, what you can do is, your A2 value is this, B2 value is this, and C2 value is this, and this is called as your D2. So you could write as minus 0.33, and your 1.473, and this value is called as your minus 0.143, and D2 value is your 3, and your A3 value is this, B3 is this, C3 is this, and D3 is this. So 0.25 and 0.143, and your minus 0.593, and this value is called as your minus 25. So now the value of your V1 is minus 21.7, and the value of your V2 is your 0.38, and your value of your V3 is your 33.09. So minus 21.7, 0.38 and 33.09. In the next video, we will see how to find the current across each element by using this nodal equation. And thank you once again. And lastly, I want to summarize. For the nodal analysis, we always use Kirchoffs current law, and while using Kirchoffs current law at any node, you want to see how many branches are connected to each and every node. First count the number of branches and then you apply the Kirchoffs current law, which will tend to give you the number of incoming current is equal to the number of outgoing current. Frame the equations like this at the early stage and find the equations. It's an easiest technique to get the decimal values at each and every fractions, because while doing fractions, many of us used to commit some mistakes. Thank you.